All right, 2015 number 5. I think this is the last FRQ of the first week here of daily FRQs. This funny little question. I see the little graphs there and I immediately know that rate is involved in this question. I already know, looking at this before they ask me, that this is going to be a first order reaction even before they ask the question, because the natural log versus time is linear. And so what we got here is some blue food coloring. It's reacting with some hypochlorite ion, that's bleach ion, and the products as a result are going to be colorless. So we're blue moving to colorless. We use a spectrophotometer, which is fun because we've used one in class, and they set it to a wavelength of 635. Why that wavelength? Because that's where the highest absorbance of the blue color is. And that's how we pick what wavelength to use when we're using the spec to look at absorbance over time for specific colors. So the student generates this data, and then we've got a couple quick questions on this thing, and these should be fast for us. The first question here, A, says, based on the graphs above, what is the order of the reaction with respect to the blue food coloring? The order is first order. It doesn't even ask us to explain that it's first order, although you should say natural log of a concentration over time is linear. And so it's first order. I would guess that they will make you explain that if you run into a question like this. If this was linear, it'd be second order reciprocal. If just plain absorbance over time was linear, then it would be a zero order. And so 0, first, second. They don't necessarily always put them in the graphs in that order, and so usually they do, but be careful, don't get caught on something silly like that. Then it says B, the reaction is known to be first order with respect to bleach. In a second experiment, a student prepares solutions of food coloring and bleach, but it says when the solutions are combined, the reaction reaches an absorbance near zero too rapidly. There's not enough time there. And so in order to correct the problem, the student proposes these 3 modifications, and it asks us which of these 3 modifications is going to help slow down this reaction. And so this is the only time I've ever seen them say you can circle something on the exam. It asks us to circle something. If we increase the temperature, we increase rate of reaction. That is not what we want. If we increase the concentration of the bleach, then it is going to be colorless faster. Increasing the concentration of the food coloring has to be our option because it's going to give us more of the blue stuff. And giving us more of the blue stuff means it's going to take longer period of time for that absorbance to reach zero. And so, properly worded, I wrote it this way: increasing the concentration of the food coloring will make the time required to reach an absorbance of 0 longer. It increases the time. And they ask you to explain that one. You actually get a point for the circling the right one here, and then you get a point for your explanation of why that's going to extend the time. And then part C, these are quick hitters. In part C, it says another experiment, the student wishes to study the oxidation of red food coloring with bleach. How would the student need to modify the original experimental procedure to determine the order of the reaction with respect to the red food coloring? So the only difference here is we initially had a blue food coloring that we did this experiment with. Now we have a red food coloring. And so if we are changing the color, we need to adjust the wavelength on the spectrophotometer. Spectrophotometer. That's it. That was their answer, just like that. You should probably extend that, because we've talked about it, and say to the absorbance that is highest for red food coloring. And that's it. Just a point for the first order, knowing it's first order. Point for adjusting the wavelength on the spectrophotometer in part C, and then you got 2 points in the middle, one for circling the right answer and one for the explanation of why that's going to increase the amount of time that solution stays blue. That's it.